Okay, hello everyone. So in this video, we're asked to determine whether the language L, where L is a language over the alphabet AB and contains strings of the form w1, c, w2, where w1 and w2 are strings over the alphabet AB that are not equal to each other, right? So an example of a string in L would be something like AACAB, right? So this is an L. Something not in L would be something like ABCAB, right? This is not in L. Okay? Excellent. So C is essentially just some delimiter that kind of tells you the difference, or that separates the string W1 from the string W2. Okay? And we want to determine whether this is regular or not. Well, I think hopefully the intuition is that this is not regular, because here we're doing something that's actually quite hard, right? We're doing something that requires us to remember what W1 was and then check that it's different to W2. So already remembering the count of a string of, say, A's, and then matching that with a count of string of B's is hard. Now, if you want to match the entire pattern along with its count, that's, in my opinion, even harder, right? So, and I don't think it's just my opinion, it's that it is harder, right? So that's the intuition that tells me that this is probably not regular. So I'm going to claim that this is not regular. And so, again, one way you could do this in terms of a proof would be to use the pumping lemma. But usually what happens where you have an inequality is the pumping lemma becomes a bit, how should I say, not super clean, I think. Like, the numerical arguments you have to make sometimes are a bit obscure, and you really have to think cleverly how you can, say, do a matching of lengths, or an inequality of lengths. So in particular, if you've seen the proof for ANBM, where n is not equal to m, right? This kind of requires you to be very, very clever about the choice of w, okay? Whereas actually, what you could do, right, instead of picking some very clever string w to prove that this language is not regular, instead, you could say, well, take L, assume it's regular, take its complement, and then intersect it with A star, B star, then that will give you AN, BN, right? And so it gives you AN, BN because the complement of this is, well, first of all, it's strings where the number of A's is equal to the number of B's, and then it's also strings that contain BA as a substring, right? So the intersection here just filters out those other strings that contain BA as a substring, and as a result, I get AN, BN. And so this is kind of where I'm headed. I'm headed from the intuition that using or direct proofs that include inequalities typically require more engineering of the string. And if I want to make my life easier, I think what I should do instead is just use closure properties. Okay, so that's instead what I'm going to do. I'm going to use closure properties. Okay, and in fact, I'm going to use this very same template. Okay, I'm going to say, well, suppose I take the complement of L. What is that going to give me? Well, I know that among the strings that I get in the complement of L, I'm certainly going to get the language, right? I'm certainly going to get the set of strings that look like W, C, W, right? Where W is in AB star. I'm also going to have other things, right? Things that are potentially, that don't contain a C, let's say. And things where the form or the pattern of the string doesn't match this exactly. And so to get rid of those other strings, what I'm going to do is I'm going to filter out with an intersection with a regular expression, right? Or more specifically, or more correctly, the intersection of a language denoted by a regular expression. So instead, what I want to do is I want to say, well, take L complement and intersect it with A star, C, A star, right? So then in this case, right, in this case, because I'm constraining the strings in the resulting operation to start with A's, be followed by a C, and then finish with A's, and that the complement contains, among other things, w1cw2, that means that the resulting language that comes out of this operation will be ANCAN for n greater or equal to 0. Right? And so, FYI, I guess to be more specific here, just a side note, L is actually a subset of ABC star, right? So this is the form of the language L, right? So when you take the L complement, this single C can actually go anywhere, and there could be more than one C, right? Because then you just get any string that doesn't look like that over ABC, right? So really, now what I'm doing is I'm constraining the space that the language can take so that it starts with A's and ends with A's and only has a single C, right? So that means that it has to be of this form, right? It has to be of this form with a C in the middle and the same string before and after, right? So then I get a string that looks, a language that looks like this, and we don't have a pumping lemma result that immediately proves that this is not regular. So what I encourage you to do is I encourage you to prove that this is not regular. I won't do it because it'll be fairly similar to other pumping lemma proofs that you've already seen. But the point here is that the result of the complement and the intersection is this other language L prime, which if you prove it, you'll see is definitely not regular, okay? But the closure properties tell us that because L is regular, L complement is also regular, and then intersecting it with a regular language also gives you a regular language. So in fact, this should be regular when the pumping lemma proof will tell you that it's not. So we have a contradiction, right? We have a contradiction, which implies our initial assumption was incorrect, right? Our initial assumption that assumed, right? So I should have said here, assume L is regular. This initial assumption is incorrect. And so, in fact, L cannot be regular. Okay? So, the one thing I want you to kind of see here is that the inspiration for a proof like this was kind of recognizing something that I had already seen, where what I already seen was this proof for n not equal to m, right, being actually quite tricky, and the complementation with the intersection giving you another language being actually a rather easy one-liner proof. And so that intuition more or less translated or transferred to this setting here, which is great because that allowed me to show that this language was not regular.